招那个
大
小抄
时候会跟期
大
末考一起
招啊，
大时候会跟期末考一起
期末考就下礼拜，对不对？3个礼拜已经学生快受不了。对，你们要想，现在16周啊，以前都18周，还多2个礼拜，现在已经比较好了。OK。老实讲，这个学期我真的是我最惨的一个学期。我到现在，你几乎我在1个礼拜可能睡8小时的，大概这5天，大概每天大概都睡不到6小时，昨天也是睡不到6，到现在也睡不到6小时。除了多上一门课，也没有多拿钱，对吧？就是那个个人抱怨。Okay. So here, okay, we are going to talk about the four focus algorithm. Okay. So it looks actually very, very easy. Okay, it looks very, very easy. Okay, but okay, let's start. Okay. So we consider the residual capacity. Okay, so we see that how much capacity is left after taking into account how much flow is going through that edge. Okay, so initially, obviously, since no flow has been assigned, so we will use the full capacity, right? So, but so this is an iteration process. This is an iteration process. As time goes by, okay. How I should say, after the first iteration, we will start consider the CF. Okay. Or you can say initially CF equal to C, but as you assign capacity, you will only consider whatever is left. So first, we find a path from S to T such that the minimum residual capacity is greater than 0. Okay, I mean, remember we use integers, right, for capacity, right? So when we say its minimum capacity, minimum residual capacity is greater than 0, that basically means it is at least 1, right? It is at least 1. Okay? So we will update the residual capacity after taking into account of this new flow. Okay? And we just repeat this process until no more such paths can be found. So if you look at this, the description of this algorithm, it's so simple. So it's very, very simple. Okay. There are some details. Okay. First, okay, we actually use DFS or DFS. I mean, I know you guys must know there are 2 ways to traverse a graph, right? One is DFS, one is DFS, right? Okay, this you may say, okay, why do I need to specifically pull out DFS? Because it makes big difference. I mean, if you don't feel like the DFS and the DFS are not very different, so this chapter, this topic will let you understand BFS and DFS are really different. Okay? So anyway, so we assume, okay, for focus algorithm, we actually use not breakfast search. Okay, not pork, but the dog. Okay, dog. Okay, so each age has the forward flow and the back flow. Okay, I mean, remember I mentioned all this, and this looks strange. It looks strange, but as we go through, actually the example I use here is really simple. I really should have talked about the sense of measurement, but I just want you to check out the example. From the example, is that why would you model backward? Okay, so the two must always be inverse of each other. When you have when you assign, say, if the capacity is 30, if you assign a flow of 20, okay, for flow 20 in this age, then the residual capacity is 10, right? Okay, and the forward flow is 20, right? The back flow is negative 20. The back flow is negative 20. Okay. So this allows for modeling of flow returning along a given age. So you may wonder, why do we need to model returning? Again, by looking at examples, you will understand. Okay. So, okay, here is the exact Schiller code. Okay. Originally, remember we haven't assigned any flow, right? So the FUV will be 0 for all ages. Okay. And then what it is augmenting, we call this like the flow. We call it the path that we can assign flow, okay, to it as augmenting path. Okay, augmenting path. And the process of assigning additional flow to an augmenting path as an augmentation. Okay. Just want you to understand some special terminology. Okay. So an augmenting path T from S to T in the receiver graph. Okay. Such that the CFUV is greater than 0. Okay. So we want to find that the path is at least some capacity is set that. Then, okay, so we find whichever that has in this path, whichever remaining capacity is the minimum. They say that if this path has remaining capacity 10, 5, 20, then obviously you can only send 20 through this path, right? Okay, so then you just find that the minimum remaining capacity in this path. Okay, and then you just then you can increase the flow for that much, and for the back flow also subtract that much for the back flow. So that's it. That's it. But you may wonder, how come we don't see that DFS? Okay, to be honest, okay, this algorithm, okay, this Schiller code can be used for two algorithms. One is for focus algorithm, okay, which they use depth search. The other one, the breadth search. The breadth search version is called Edmonds Carr algorithm. You say, oh, just the First is references difference. How much difference does it make? Yes, it makes difference. Anyway, let's come back. Let's look at it. Because this one is too simple, so it's probably difficult to show like the difference of references and references. But I just want to first discuss like how it works first. I mean, this example and this hopefully I can explain to you like why we need to model backward. Okay, there are two important things to cover here. The first one is why do we need to model backward? The second one is what's the difference of reference search and backward search? Okay. But honestly speaking, I don't think we can finish discussion today because like it requires so many people. Okay, so here's the thing. This is like the original, flow network, right? So we start from node S by using the DFS. So DFS, here, okay, we assume, okay, the first, because it's DFS, right? So DFS, it is very important that you will, what should I say, you will not necessarily find the shortest path, right? From the source to the sink, okay? So, see, here, okay, I mean, the shortest path from S to T, obviously, is either this one or this one, right? The top one, S to U and S to D. I mean, either of these two paths obviously are the shortest, right? But remember, we are using the backward search. So we are not necessarily identify the shortest. So set initially we find this one. We find this one. So according to the algorithm, how much capacity are you going to assign? According to the algorithm, how much capacity are you going to assign? Because this path, you look at the capacity. I mean, you have 20, you have 30, you have 20, right? So obviously, you are going to maybe let me copy the block so that I can write something. So we have S. We have U. We have E. We have T. Right? And then, okay. And this one. This one. This one. Okay. So, let's consider the flow assignment and the back flow. Okay. So we will assign 20, right? So after assigning 20, this is the remaining capacity, 0, right? Here. Okay. The remaining capacity is 0, right? Okay. And then the forward flow is 20, right? Because we have three numbers. This is a flow from S to T. This and this, the back flow is negative 20. Okay, we have negative 22. Is that right? Okay. And the middle one, from U to V, okay, we take 20, right? So it's going to be remaining capacity is going to be 10. And we use 20. And it's negative 20, right? Right? And from V to T is going to be 0, 20, negative Okay, we still have two other ages. So it's 10. 0, 0, right? That is this one is 10. 0, 0, right? So far so good, right? So we will then use another depth search. I mean, remember, we are going to look for the ages that has remaining capacity. Okay? I mean, let me correct myself. It's going to be the age with either remaining capacity or with non-zero backflow. Okay, why? Let's look. Okay, so we will do this, right? So this is 10. That one is 0. So we'll do this one. And then, because, well, it has remaining capacity 10. And then we go from up to here. So after the update, this one becomes 0, 10, negative 10. And this one becomes what? Okay. We actually take this one. So what happens is that, okay, because it has negative 20, right? So we actually send the parting flow back. So what happens is that this one will be updated to like 20, 10, negative 10. Okay? And this one will be 10. 0. So 0, 10. Okay, because we will use this one, this one, this one. Okay. So after the sign, think about this. We send 20 here, right? And then 10 goes here, 10 goes there. Okay, and we send 10 here. And another 10 comes from here. And 20 goes here, right? Okay. And the intermediate node, remember the intermediate node, I said like the incoming flow and outgoing flow should balance, right? Should balance. So you can see this one, incoming flow is 20, and we have outgoing 10 here. And for this node, incoming flow is 10, and another 10. We have outgoing flow 20 here, right? Okay? So we use that back flow, okay, in order to utilize, this age. We utilize this age. If you originally set like 20 here, originally you already use think about this. Previously, if you already use like 20, and this one you finish at 20, and you use 20, you send like flow here, and then you couldn't make use of this 10 if you do not have that backflow, right？ 就说这个 backflow 啊，主要是用来干嘛？用来 model 这个，就说有时候你这边其实 其实你送20哦，你送20，没有用到这边，你送20到这边，其实你有些可以这样子做，或者说你可以讲说你原来用的这个，你用了20，这件事情是其实应该有10往这边走。但是如果说你一起走到这边的，那因为你用 DFS，所以你这边走20，那你这边这个10，因为你下一个从这边走，你这边已经20用掉，这已经断掉了，对不对？对不对？你如果说没有这个 backdoor 来去 model 这个东西，你这边要再出来10，没办法出，连10出来。因为你这边怎么讲，理论就只有往这个方向。你如果不用这个 back row， 你没办法上去。那你这边的这个，因为这边20用掉，在前面第一个 match 用掉，对不对？如果你不用这个 back row， 你是没有办法 utilize 这个 pass。这个是那个 for focus 演算法里面一个很特别的地方。You have to make use of that back row in order to maximize. I mean, at the end, the maximum for is 30. That's true. Okay, but for complicated cases, like it will be difficult to observe. So this one is relatively easy. Okay, it's relatively easy. So this is the core focus. So for and then what is the training process? What is time complexity? The time complexity discussion is actually much easier than you may think. It's going to be E times F. What is F? F is the maximum capacity. Okay, so the complexity has something to do with the maximum flow. Okay, why? Because in the worst case scenario, okay, it's going to be proportional to the maximum flow because each time, I mean, where does E come from? The E comes from the depth of search. Because we know the depth of search is V plus E, right? V plus E, and it is bounded by E. Okay, so but how many times you are going to run this depth of search? It depends on how much you can utilize this. So you may say, oh, then what if we need to run this F number of times? It sounds stupid, right? I mean, does that mean that every time you just find that row 1? 就为什么我们用 F？ 我说，难道我每次都只找一个 row 是unit 1的吗？有没有这个可能性？ The answer is yes. Actually, if you use depth first search, your algorithm may end up so stupid that every time you only increase the capacity to 1. Let me give you an example. Let's go 2000. Let's call it 2000. Let's call it if algorithm, you know, unfortunately, the algorithm, you know, actually from our example, we should already observe that. But let me use this example, and it will be more obvious. Like, if you look at this, you will obviously see that, oh, the capacity is 4,000, right? It's 4,000, right? The capacity is 4,000, right? Because 2,000 goes from the top, 2,000 goes from through the bottom path, so it will be 4,000 in total. But think about this. If you use that first search, the first time you could end up finding this one, right? You could end up using like this middle path, middle edge. If you use this middle edge, you know the maximum, the minimum flow, the minimum edge in this path is going to be 1, right? It's going to be 1. So it's going to be this one, when you have a 1, you really like that 1, but you have a back flow, negative 1, right? And this one, 2,000 becomes 1. So this is the first try. The second try, you may end up using this path. Because obviously you can make use of this, back flow, right? So this one becomes one again. This one becomes 199. This one becomes 199. Right? So every time, you know, if you do this alternative, if your algorithm is so stupid that every time you try to find that edge between UV, you try to involve that edge, you know, between UV in your flow, then, you know, every time you only going to increase your flow capacity by 1, right? Yeah, this algorithm will keep running, right? You keep running until what? Until the 2,000, you know, with the other path, exhausted. So it takes like 4,000 times, right? So that's why, okay? Yeah, it's going to be E times F. It's something to do with the capacity. Because that first stage. Okay, this is that first stage. Okay. So as I said, we can use the breakfast stage. If we use the breakfast stage, I mean, it will be different. It will be different. So minimum flow of the augmenting path is 1, worst case. So the maximum number of steps is that's what I'm saying. Maximum flow. Okay, at the end. So if this path T from S to T, okay, that research is the 4 opposite values. So each orbital path can be found equal to the number of approaches, and there can be remember at the beginning I told you like, oh, we use the integers, right? We use integer as a capacity. Why don't we just use the fraction, you know, to represent capacity? Because if you use fraction, I mean, you have like no, what should I say, like, you cannot guarantee like every time you substitute one, blah, 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 later you will reach 0, right? But they say, then we use we could use rational number, right? Rational number means like it's like a fraction, yeah. Then we multiply like a certain number to make all the number integers, right? Make all the capacities integers, and then you can use the whole values. But if some edges have irrational edge and irrational capacity, then you couldn't find any number to multiply to make it into the integer, right? So that is why we said, I mean, yeah, it's okay to have fraction as long as it's rational. Okay. Rational. So it should be not rational. Like what's quotient, right? Quotient. And if a capacity can be represented by P divided by Q, okay, that's fine. Because we can multiply some number to make it integer, right? Okay, so that's fine. But you know, if it's like if it's rational number but it's not quotient, 如果它是有理数，但它不是这个中文叫什么？quotient叫什么？哦，如果它是实数，但不是有理数。对，应该是这样，是实数，但它不是有理数。可以偏好的 ，OK， 那你找不到任何的指数，只其他的指数，那 then we have a problem. Okay, so this is also something to discuss. Why we need to make like a capacity integer? Because you know, if it's not integer, if we cannot make it integer, then we have no way to stop it, right? To terminate. So, if you use a breadth search, the good news is that, okay, I mean, it has different things called element time. And the running time now has nothing to do with the maximum work capacity. It will be like n times n squared. Because the total number of augmentation, I say augmentation basically is that the number of augmenting path you could find is bounded by bit or n vector. And find each augmentation can be open. This one is basically this cost is the depth search, breadth search cost. Breadth search cost is also like E cross E, right? Okay, and this E pretty much bounded. So you only consider. So here, by using this, we guarantee determination. I mean, even with irrational age value, even when your ages cannot become integer, we can also do that. Okay? And the running time is dependent on the maximum point of the clock. So let me use this, let me illustrate that. And then hopefully next week I can talk a little bit about why. breadth-first search. If you use breadth-first search, you are going to explore these two nodes, right? You are going to explore U and B, right? And depending on the order, the next one will be, P, right? Well, if you use U, the next one will be, from S to U, and then from U to E and P. But, you are going to find the P in two halves, right? No matter you go from the top one or the bottom one, it's going to be two halves, right? So you're not going to take this one. Okay? So what happened is that after, because we try the top first. So obviously the capacity become what? 10 or 0, right? So capacity become 10 or 0. And we still have capacity searching. Capacity 10. So the next one we try this one. What happens is that, okay, this one becomes 0. This one becomes 10. Right? Right? So, the third time, because this one capacity 0, so you will try this one, this one, this one. And then you may use in the middle. So this one becomes 0. This one becomes 20. This one becomes 0. And the maximum capacity is reached. Right? Right? So, the important thing here is that, you will try to find the shortest path. Well, you continue to try to find the T with the shortest path. And then, by doing so, the reason you end up having 4,000 because it involves this one, right? This is not usual. It cannot be the shortest, among the shortest path. Okay? And we will discuss that. We'll talk about the proof next time. Okay? But I just want to point out, okay, the Edmond Edmond's car. The only difference between Edmond's car and Ford Focus is the BFS and BFS. But you see that the difference is huge. Okay? So this is something that you can consider. It always usually you see, like the BFS and BFS it doesn't make much difference. They are all like graph traversal. No, it makes a difference. Okay, because by doing so, we actually limit the number of augmenting paths. Okay, so if it's this one, you can see either you go top, so go 2,000, 2,000, and the next one you go 2,000, 2,000, you go down. This one, that's the concept. You go down. So you get 2,000 in two augmenting paths. You will not bother by one. Okay? So we are going to talk about this in more detail next time. And hopefully finish this chapter. we have time, things are to be complete. Yes, okay. That's it. Okay. And I will assign the last homework, and which make a little amount for this week. Any question? If no question, I will see you next week. Okay?